Hi all, my name is Tony Larsson and I'm from the Designed agency. And in this video, I want to discuss how to create plastic parts in different quantity numbers. So let's say that we have one extreme case where we just want a few parts, maybe 10 parts, which manufacturing technologies will be relevant there. And then we have the extreme case where we are manufacturing tens of thousands of parts. And then the question is what will be applicable there. But before I delve into the different variants of manufacturing technologies that do exist for the different unit numbers, let me just briefly say why this is a question that comes up so much in our design work. And that is because plastic is an awesome material. If you put weight, strength, and cost as a triangle, and then map that out with many plastic materials, you will see that the combination of those attributes is just so good for plastics that it's oftentimes not possible to avoid using plastic and still be competitive in the market. Then how do we actually go about creating parts in the different cases? And let's start with the case of having a very small production run, a very small number of units, and then work ourselves up to the case where we are producing tens of thousands and maybe even hundreds of thousands of parts. So starting off with the very small case, we can imagine that we are a startup and we don't want to invest a lot of money into creating molding and tooling for a part, which we don't really know that customers want yet. So we are in the product market research phase still. Okay, so in that case, we might want to create only 10 plastic parts. So I have a plastic part here. And if we want to create 10 of these parts, then I would say that 3D printing, it's almost certainly gonna be the most sensible choice for you. And the reason is that 3D printing, it has a very low startup cost. It's almost zero. And then it has a very high unit cost, which is of course very design dependent. But for something like this, the unit cost could be maybe $5 to $10, depending on what type of 3D printing you are doing. But the point is that 3D printing will allow you to create these plastic parts, try out the market demand, create maybe 10 prototypes or alpha versions of your product, and then get feedback before investing into a much larger run. And there are very few examples of products at the moment which use 3D printing in mass manufacturing. So I'm talking about tens of thousands of units. And the reason is that for most conventional 3D printing technologies, the unit cost is just too high. It takes too long to create parts. So for example, a part like this could take maybe half an hour to print. And of course, when you compare it to other manufacturing technologies, that's much higher, an order of magnitude higher. So 3D printing, very good, but only for very low quantities. To make it more concrete and try to put some numbers on these very design dependent things, I would say that 3D printing, it's good up to 10 to 50 units. But once you go past that point for most products, it does not make sense anymore. Once you go past that point, I would say that then casting of some sort makes more sense. And casting, to describe the process very quickly, is where you print a master, you create a master part. Around that master part, you create a mold. And the mold, of course, it's a negative of the part that you actually want. And then you fill this mold with a material for plastics that could be a resin, which can cure at room temperature. And when it's cured, you open the mold up and you extract your finished part. So casting, that is great for this mid type of unit numbers. So from 50 to maybe 500, 1000, this is again very dependent on your product, because maybe your business model, it is permitting you to spend a lot of money on a single product. So maybe you are in the medical field and you're only selling a few per year. Well, in that case, maybe casting is the best choice forever, right? Maybe you never hit a point where you need anything more than a casting. Or maybe even 3D printing could be the perfect choice for your business. But if we are talking about consumer products, where we will be producing a massive amount of a number of these parts, and where we need to be very price competitive for consumers to buy our product, then we need something more than just 3D printing and casting, most likely. And that something is injection molding, and you have probably heard of it. And now let's discuss the benefits and downsides of injection molding. So the obvious downside of injection molding is that the startup cost, it's extremely high, right? So for a part like this, I actually have some sourcing numbers and the cost estimations that I got from different factories in China, and I'll put them on the screen right now. And as you see, the tooling cost, it's extremely high. However, if you look at this column right here, you see that the unit cost, it drops so drastically compared to 3D printing or casting that it really makes it worth if you get into these higher number of parts. And the tooling for injection molding, it can range from $5,000 for a very small and very simple part to 100,000 or even more for very complex parts that require a lot of different complications. And here is the main problem that I see right now with these different steps, because like I said, 3D printing, it's good for maybe up to 10 parts, maybe up to 50 parts, but after that it just does not make sense for most businesses. Then casting, it's good for maybe up to 500 parts, and again we're talking about plastic, right? So I'm only talking about plastic manufacturing right now. But then injection molding, the benefit or the rationality of injection molding, it only kicks in after maybe 5,000 parts. So there's a huge gap from casting to injection molding where you don't really know how to do it. And this is why oftentimes you do need quite a strong conviction and validation of your product idea to be able to make it, because injection molding, it is the standard. And when you get there, your unit cost will drop so drastically that you can become competitive with the already existing products on the market. But until you get there, you need to keep validating your product and make these smaller runs with casting and maybe 3D printing, and save up basically for investing into the mold. And I would love for some kind of mid alternative here between casting and injection molding to emerge. There has been a lot of work on 3D printing to print faster, print more affordably, but I still think and have seen that the numbers simply don't make sense for most businesses. So to summarize, we have 3D printing for a very small number of parts. We have casting for the mid-range of plastic part manufacturing, so maybe up to 500 parts. And then we have injection molding where we get into the really, really large numbers. And this is what we're gonna use anywhere from 5,000 parts and up, most likely. And that's basically it. If you are interested in learning more about plastic part manufacturing, about what makes sense for your business, then feel free to contact me to book a call. And also feel free to check out the course that I did on this exact topic, where I go through everything for how you get your napkin sketch idea all the way to market. So we go through sourcing parts, we go through manufacturing, we talk about how to actually work with designers and engineers to get your product into your hands. And if you're interested in taking your own idea and launching it, then check out the free trial that's available in the description. And thank you for watching the video, and I hope to see you in the next one. Bye.